All right, let's do the review. The first semester final review is cumulative. So for 3, it says find f of 3. So that just means that x is equal to 3, and we're going to replace x and simplify. There's going to be no moving across the equal sign because we're simplifying. So for number 1, that's going to be f of 3 is equal to 3 times 9, which is 3 squared minus 15 minus 4. So 27 minus 15 minus 4, that's going to be 27 minus 15 is 12 minus 4. It's going to be 8. So f of 3 is equal to 8. That just says when I plug in 3 for x, I get out 8 for y. When I do that to number 2, f of 3 is equal to 3 to the third power minus 27. That's 27 minus 27. So that time f of 3 is equal to 0. I don't know what that little thingy is here. Yep, no clue. All right, then on the third one, f of 3, so we've got f of 3 is equal to 2 times 3 to the fourth power. So 3 to the fourth is 81 minus 3 times 27 plus 8. So 162. And then 3 times 27, that's going to be 81 also, minus 81 plus 8. 81 plus 8, 89. So here f of 3 is equal to 89. So those ones are great. On the piecewise functions, in this case, we've got to do a little bit of work because we've got to determine which inequality. So which inequality does x match? Use that equation. So f of -5 is less than -3. So I would use 2x minus 5. For f of 1, I have to use the bottom equation because that's underlined. And then for f of 6, I'm going to also use the bottom equation, x is greater than or equal to 1. So that's going to be -3x plus 7. So now that I know what equation to use, I'm just going to do the calculation with that. So I'm plugging in x just like I did before, and that's going to be 2 times -5, -10 minus 5, -15. F of -5 is equal to -15. For f of 1, -3 times 1 plus 7, -3 plus 7 is 4. So f of 1 is equal to 4. And then here I'm plugging in 6. That's going to be -18 plus 7. That's going to be f of 6 is equal to -11. Right on. So these evaluating, we miss these. These are kind of nice. Just simplification, not solving. For 7 through 10, the piecewise functions, we need to draw a vertical line at x equals. So in the first one, it will be -5 and so on. So remember, this is the x-axis. Here's the origin. So -1, 2, 3, 4, 5. My vertical line. This is where I met my function. And I want the y value. So the y value there is -1, 2, 3. And so the answer is just the y value. When we go to -2, I draw my vertical line. This is an open circle here. we never use the open circle as our answer. So my answer is up here where it hits at 1, 2, 3, 4. For f of 4, oh, sweet. It's right here. So the y value there is 0. And then for f of 7, -2. I love those. Those were fun. Okay, so simplifying the radical expressions, we're going to look for our square numbers as factors. Those are 4, 9, 16, 25, 36, 49, ... You know, those numbers. And when one of them simplifies, make sure to take it out of the radical. So 324, that's going to be 4, and that will be 81. And these will both actually simplify. The square root of 4 is 2 times the square root of 81 is 9. So this is 18. For 150, that's 25 times 6. So that's 5 rad 6. For -169, the square root of -1 is equal to I. Super importante. And so this one is just 13i, because the square root of 169 I've memorized. Looking at number 14, when I divide that by 5, I got -49. So taking the square root of these, the square root of -49 is going to be 7i. And then I still have rad 5. Final answer. So then I'm looking at 15, 16, 17, 18, and 19. And they all look very similar. They have those complex numbers, but in 15, we're going to use FOIL. In 16, we just add. In 17, we again use FOIL. In 18, we distribute the negative, changing both of these to plus, and then the middle to plus, then add. And in 19, it's multiplication, so again, we FOIL. So FOIL is an acronym that talks about the double distributive property. If you prefer to use the box method, I saw some of that on your guys' work. We can do that. I'll show that here. So this will be 7 plus 6i. So I've used that one. So I do 4 minus 3i. And then in the box, you just go like this, and it kind of shows the multiplication. So 7 times 4 is 28. And then I'm going to go across. 4 times 6 is 24i. Then 7 times -3, -21i. And then 6 times -3, that'll be -18i squared. So I squared is like this I over here. To the second power, it cancels out. And so I squared is equal to -1. So that's really important. I capture this whole thing. That's going to be -18 times I squared is -1. So that's going to change to plus 18. So then the numbers that we add together are the numbers that don't have I. So that makes 46. And then these ones at the diagonal, I can add those together, right? And that's 24 minus 21, so plus 3i. Final answer. 16 is much easier. 8 plus 13 is 21. And 7 minus 2 is plus 5i. Maybe you can vaguely hear Let It Go in the background. My daughter's watching Frozen. Okay, so let's FOIL number 17. This time I'm going to show it with first, outside, inside, last. So 4 times 4 is 16. What I like about the box is like you can't mess up with the number of terms because it kind of shows it. But here, this would be minus 4i plus 4i, and then it would be minus I squared. So when I go to combine my like terms, I see that this cancels out, and here I have negative I squared. We need to note that that's negative 1 times I squared, which is negative 1 times negative 1, which is positive 1. So it's really important on this one to show a lot of work. So I have 16 plus 1, 17 is the final answer. For number 18, I already showed that we're distributing, and then we switch the signs on the second one and just add. So 1 plus 3 is 4. 4 plus 8i is 12i. And then for number 19, I can FOIL that again. I'll show the box method one more time. 9 minus 5i. 9, plus 5i. What's going on? So 9 times 9 is 81. I have minus 45i. Here I have 45i. And here I have negative 25i squared. So the negative 25i squared, that's going to be negative 25 times negative 1, which I know is just going to become positive 25. So these numbers cancel out. 81 plus 25, that would be 106 as my final answer. Great. So looking at 20 through 23, evaluating the powers of I, we have to remember that I works in that mod 4. So we divide the exponent by 4, and then the different decimals tell us the solutions. So when I have 0.25, that's I to the first power. That's like remainder 1, which is just I. And then if I have 0.5, that's remainder 2. And that's the exact same as I to the second power, which was negative 1. Then if I have 0.75, oh man, I wish I had written this nicer. So if I have 0.75, that's the same as the remainder 3. So that's going to be I to the third power. Okay, let's see. 0.25 I to the first. 0.5 I to the second, which is equal to negative 1. 0.75, that's going to be I to the third power. That's negative I. And then I have 0.0, right? It went in evenly. That's I to the fourth power. Negative 1 times negative 1. That's going to be 1. So these are the 4 that you need to know. So I divide the exponent by 4. 99 divided by 4 equals 24.75. So 0.75 is I to the third power, which is negative I. I to the third power comes from I to the first power times I to the second. So as long as I know, okay, 0.25 is remainder 1, that's I, and I know that 0.5, or that I know that I squared is negative 1, you will be able to figure these out. So when I take 33 and divide it by 4, I get 8.25. And so that's going to be I. 252 divided by 4, it goes in evenly, what is it? 63. There's no remainder. So that's just 1. Which is pretty cool. That kind of makes sense. It went in evenly because there's no remainder. So great. Now we're looking at factoring. So we've got factoring, and we are going to look always for a GCF first. And then we'll use the t-table only if it's a trinomial. And then if it's a binomial, we'll look for difference of two squares or sum or difference of cubes. So 23 is unique in that it has, it's a binomial. And I'm going to look for the GCF. I definitely see that the letter B is present in both. And the highest power is in the first one, and just b to the first. And then they can both be divided by 3. So remember, I used to call these little baby. So we put the baby out front. And then we do the division, and I have A, and the b's cancel out, minus the 3 will remain, and then the b will become 1 less powerful. And that's it. Check out my GCF. So for 24, that's a trinomial. Uno, dos, tres, 3 terms. So I make my t-table. I want the numbers to multiply to 6 and add to -7. So that's going to be 1 and 6. 1 and 6 add to 7 for sure. So if I make them both negative, they'll multiply to a positive and then they'll add to a negative. So y squared minus 1y minus 6y plus 6. Now we go in and we draw the fence. I just want to be able to change colors more easily. I just don't know if I can. So I draw the fence, take out the GCF of y, and I have y minus 1. Take out a minus 6, and that becomes y, and change the sign to minus 1. The binomials have to match, or you've done it wrong, and we have y minus 6 times y minus 1. Beautiful. On 25, I'll do the same work because it's also a trinomial. So we got 16 here, 64 here. Oh yeah, 64 is 8 times 8. There are no negatives, so I don't have to worry about that, anything being negative. So this will be f squared plus 8f plus 8f plus 64. Then we draw the fence. So that gives me f on the outside, f plus 8. And then this time a positive 8. And then again, f plus 8. And we get f plus 8 times f plus 8, which you could also write that as f plus 8 to the second power. There are 2 of them, multiplicity of 2. All right, 26 is another trinomial. And looking at it, oops, I see a negative sign. So I've got -40. And I have positive 6. So I'm going to want 1 negative and 1 positive. 1 and 40, 2 and 20, 4 and 10. Okay, 4 and 10, they have a difference of 6. I want the 6 to be positive, so 10 minus 4. These are going to be the combination. It's really, really important that your sign matches the answers. So 10 minus 4, positive 6. Writing that out, it's x squared minus 4x plus 6x minus 40. Then we go in and we draw the fence. Oh, it didn't color change. All right. X minus 4. Taking out the 6. I wrote 6 down. That's good. That's really good. Why did I write 6? I just did by accident. So I found my mistake. I'm going to change that to 10. I take a 10 out of here, and then it's going to be x minus 4. The binomials match. So I have x plus 10 times x minus 4. Okay, number 27 is not like the previous problems. So 27 is the sum of two cubes. I can tell because it's exponent of 3. So I notice that I have to take the cube root then. So I'm trying to find what was the number. So it's 2x plus 1. I call this one a happy face. So I'm going to do 2x times 2x to create the trinomial. That's 4x squared. And remember that acronym SOAP? That has to do with this. So the sign here is the same as the original problem, plus plus. This sign has to be opposite. So here I have a plus, I want a minus. And then the last sign is always positive. And that's where we get the word SOAP from. So I did the times by itself. Now I do the times together. 2x times 1 is 2x. And then finally I do the last one, 1 times 1, which is again 1. So that's all we have to do for when it just says factor. In unit 3, we had to factor and solve. So this was pretty great. All right, back to a trinomial in 28. So a trinomial, the B value is 13, A and C would be 30. Oh, this is great. It's all positive, so I know it's 3 and 10. So 2, I'm going to change it to x squared plus 3x plus 10x plus 15. Drawing the fence, got x, 2x plus 3. And then what can I take out of 10 and 15? A 5. Positive 5, 2x plus 3. So then my final answer is 2x plus 3 times x plus 5. Very nice. Looking at 29, I see that is a trinomial. And of course, I noticed that there's an x in the last term. So I see that the lowest exponent is x squared. That's the GCF. So taking the x squared out, I make everything 2 less powerful. Great. Now I have a trinomial inside here that I want to factor the same way that I've been factoring everything else because it's a trinomial. And so I factor that. The B value is 2. Multiplying 3 and negative 40, I get negative 120. So now I'm looking for the values to have a difference of 2. So close in number. So close in number, 10 times 12. Yes. So who should be negative to make positive 2? The 10. So 3x squared minus 10x plus 12x minus 40. Drawing the fence. I'm taking out the GCF of x, and it's 3x minus 10 plus, I can divide 12 and 40 both by 4. So 4, and then it is 3x minus 10, which is great. So my final answer here, I have to kind of write it over here. I've got the x squared. I remembered my baby. And then I have 3x minus 10, and then also x plus 4. Goes to 29. Wonderful. Looking at number 30, that one's the difference of 2 squares. This one's my favorite. This is just x plus 12, x minus 12. Of course, what am I saying? The letter is W. Reminds me I forgot to change 28 back to a C. Whatever. This is a W to be a good. There we go. Final answer. And then these should both be C's. just so that it matches. Right on. In 31, hopefully you see that there's a GCF there also of the letter A. Taking that out, I've got 5a squared plus 14a minus 3. Thinking about my t-table, I'll do it here. I've got 14 as the b value, and then multiplying 5 and negative 3, I got negative 15. So I know it's 15 and 1. And I want them to multiply to a negative. So I'm going to turn the 1 negative so that it becomes positive 15 minus 1. So I've got 5a squared minus 1a plus 15a minus 3. Taking out the a, I've got 5a minus 1. And then we're taking out a 3 over here. So plus 3, again, 5a minus 1. So the final answer has the first a that I'm remembering, a, then 5a minus 1, and then also a plus 3. Putting those numbers outside together. That's lovely. Now looking at 32. Oh, I'm yawning. So you're in 32. Love it. We see that this one has an exponent of 3 and that it's a polynomial, not a trinomial. So on polynomials, we go right to the fence. We love these. I take out the GCF, it's x squared this time, and I have 4x plus 7. So we always take out the lowest exponent that's shown, which was 2. And then seeing that this 40 starts with a negative, I have to take out a negative, and they both have a 0, so negative 10. That gives me 4x plus 7 also. Putting these together, I've got x squared at minus 10 and 4x plus 7. That's my final answer. If this had been x squared minus 16, we would keep going to get x plus 4x minus 4. But it's not, so we're done. Okay. 33 is a trinomial, so I'm going to factor that one the way I've factored all the others. Making my t-chart. B value is negative 30 and 9 and 25. Let's see. 8 quarters is $2. So yeah, 225. So it's interesting. We needed to multiply to a positive and add to a negative. So we want 2 negatives. They're both 15. So now I've got 9a squared minus 15a minus 15a plus 25. Taking out my GCFs, 9 and 15, 3a. And I have 3a minus 5. And then again, it starts with a negative, so I've got to take out a negative. It will be negative 5. And again, 3a. Switch the sign, so minus 5. And good, my binomials match. I have 3a minus 5. There are 2 of them. So I'm just going to write it as 3a minus 5 squared, like I had on that previous problem. Wonderful. Okay, 34. I look at 34 and I can see that that's an even exponent, not a 3. So it's the difference of 2 squares binomial. Taking the square root of both of them, I get the plus and the minus. So the square root of x to the 4th is x squared. Square root of 16 is 4. And then this one has a chain reaction. So I have the same pattern again, x squared minus another square. So take the square roots here. And I get plus and minus x plus 2, x minus 2. Oh my gosh. And x squared plus 4. Oops.